Hi, I'm Andy Jacobs with Accurex.
And I'm Brett Kroening from Boelter. Andy and I have had a dialogue today about holistic approaches to design of food service venues. We'd like to show you a few of the videos from that today.
Thank you for taking time out of your day today and joining us. What's the first thing that you think about when you look at a new space, as far as, what does that kitchen space impact on your design?
Yeah, Andy, the first thing that I generally think about is flow in and out of the food product and how people are going to sort of work in that space. So how are you going to get the food in? How are you going to get the waste out? Where's the food being served? And that kind of plays into the size of the space based on if it's enormous space, say we're turning a warehouse into a restaurant. In those instances, we may really be needing to think a lot more about how we're going to cover all that ground and still keep food warm, how to get that food production and prep closer to the cooking and closer to the end service element, be it a waitress pickup or be it something where people are coming up to a service window to collect themselves. But yeah, in general, we're looking at those flow points to start, regardless of the size, right? But then as we start thinking about diving into the design further, we've got those flow points, we've laid out where the hood is, we've laid out where the walk-in cooler, freezer, dry storage are. Generally, we're starting with that hood just because it has so many sort of factors mixed in, right? We've got exhaust going out, air coming back in. So we get that located, then we talk about where the walk-in can go and where the flow leads into that, and then we're thinking about prep sort of fitting in adjacent to those spaces.
Yeah, absolutely. So as you're looking at the space overall, then you're kind of figuring out maybe where to put the equipment. From a cooking standpoint, I know you mentioned from a flow standpoint of you want to make sure it's hot, right? So that it flows well that way. But how do you pick and choose where a fryer goes, where a griddle goes, where a cook and hold,
specific to the hood, right?
Different things. Yeah,
definitely. Yeah. So first question is always do you have any big grease producers? Do you have a charbroiler, right? Ideally, we get that charbroiler centered in that hood cavity.
Yes,
so if we have a 15-foot hood, we really don't want to see that charbroiler, regardless if it's only a 2-foot unit, way out on the end. And I mean, you can speak to some of that detail on how the air handles and how that effluent's going to travel. Right. But clearly, right, if we can put it in the middle instead of way off to the edge, we can suck up a lot more of that effluent. And contain it a lot better, right?
Yeah, we want to keep that smoke and grease and everything just contained as much as we can, like you said, right in the middle of it. So it's great when that's kind of where the design starts, right? Where you can kind of dictate some of that. So would you say, do you kind of try to steer where things go, or is it more of just a general conversation with your customers too, and the owners, operators of how they want to and how they see most of their different cooking and operations going?
Always owner driven, right? I mean, always based on what that customer's needs are. If the charbroiler and that component are more of a nice to have, like maybe there's a few grilled products that we're doing, but generally speaking, it's not the main dish that's being served on there. That really works well if we can kind of just tuck it in the middle, right? But if we've got a situation where grill is clearly on the right, fry is clearly on the left, well, then we might have to locate that charbroiler over near the edge. But then we can talk to Accurex about things like end panels, or maybe we can put a wall there, right? A small piece of wall to capture that effluent. But yeah, always talking to the client about what they really want for flow and how they really want that to work. Is certainly where we start. And then of course how that marries up to some of their other service elements. Always, yes.
Would you say that it changes things whether you're looking at more of a front of house, kind of in like a space where we're sitting right now, versus a back of house, when you're looking at overall just looks, design, things like that. I mean, when we think about our kitchen ventilation systems and our hoods, we base all of that basically over where you guys place or want to place some of the different appliances and what the different space actually looks like. But can you speak a little bit to how you look at front of house and back of house?
Sure. Yeah. And the volumes associated with that, right? So if we're in a situation like we are now, where the front of house has great volume. We have very high ceilings, tons of air to pull from. There's good and bad with that, right? I mean, we have all that open air volume to draw air to the hood from, but we've also have that ability to sort of have a lot of air, potentially dirty air, leaving that kitchen space and getting out into this nice ornate area. So in those instances, right, we're really thinking even a little bit harder about where we're placing those components.
Yeah.
And it's, again, trying to keep those grease producers in a place where they're going to do the least damage to the air volume and give you guys the best chance to capture.
Yeah.
All the while thinking about noise, right? Because here we go, we put a lot of grease producers out front, potentially. We got to crank the airway up, and now all of a sudden it's noisy. And you know how that goes. We've got a whistler, you know, the old whistler. We have the hood buzzing, and everyone's like, why is that so noisy? Especially when you first walk into the space, right? When the space isn't in use and doesn't have any people in it. And we turn that hood on and we're doing some test grilling or something. Holy mackerel. Right? It sounds like a jet engine.
Yeah, you got to think of the acoustics of the space then too.
Yeah. So, and that's always tricky, right? We got a big air volume, we can pull out air, but now we're out in the front and it might be noisy. To your point, if we can do that cooking, some of that real heavy grease-laden cooking in the back, maybe there's some show that we do out front, but we sometimes talk to clients about how we can do production, sort of grill off or potential cooking. And a lot of this is owner-driven and chef-driven. They'll come up with a way to par cook their burgers, for example, right? We bring them out and we just basically flash them in front of the customer. We're still selling that sizzle. We're still giving them excitement, but we're not burning all those fats off onto the charbroiler and then putting them in the hood. Because I mean, it doesn't look very well either when the back plenum is covered in grease.
Yeah, it's kind of a catch-22, right? Where you want it to look really nice. You want everything to look pristine out here, whether it's from, you know, just the overall looks of the appliances, but then, like you said, you want to have some of the show, right? Some of the sizzle factor.
Yeah, right. It all kind of comes down to the flow, right? And again, we always start with that client relationship and talking to them about what they're, you know, what concerns them about flow. Because you're always going to have a bottleneck somewhere. Ideally, you wouldn't have a large bottleneck, but you're kind of always going to have some place that's not quite as efficient as some other place, right? And we, generally speaking, like to see that sort of maybe happen in the dish room or somewhere that's on the tail end of the operation, not customer facing, but something that's coming off of the customers, right?
Yeah.
So yeah, we're always trying to think about how we can lay out that storage operation so it's most convenient, but yet not, you know, we don't necessarily want it to be too far out front to where you can't have replenishment. You know, if someone comes with a delivery, you don't want them running right through the middle of the kitchen operation to deliver some product to the walk-in cooler or freezer or something. But certainly we want that product to flow out of there smoothly to preparation, right? To where we can prepare that food for cooking operations or potentially right for service. And then sort of work that into that size that we talked about earlier where, you know, if it's really big, we want to make sure that we're not taking a ton of steps from one place to another just because these things are so spread out. I'd like to keep it compact, but yet not so tight that you can't move around.
Right.
In a place like we're in now, for example, when you're really pushing hard for a very short period of time and there's just a ton of people, way more people than you'd normally have in a kitchen operation that runs 24 hours a day, for example, where maybe you only have a cook, a dishwasher, a few wait staff, and that's it, right? In those areas, you might want a more compact operation because those individuals aren't crossing each other a terrible amount.
Right.
Whereas in a situation like this, we've got people that are in redundance. I mean, there's many people doing the same type of operation all in the same space. So we might open things up and spread them out a little bit more, and they may feel kind of spacious when it's not in full operation.
Yeah.
But certainly once it fills in, it feels more normal. Yeah,
and I think that probably plays into, you know, different efficiency things too, from, you know, like an energy efficiency standpoints too. You know, different institutional types of locations, you know, hospitals, different things like that. You know, where different systems may, you know, play better than others. You know, like, you know, you look at a variable volume system for, you know, like the kitchen ventilation system, where, you know, you're going to have those peaks and valleys during the day. So, you know, you don't want to just have it running constantly all the time. But then when you look at, you know, maybe more of like a stadium or an arena, you know, you have concession stand operations, right? Those are running, you know, for game days, right? 8 hours a day, maybe something like that, just to get through the prep and everything else. Like maybe there's not full need for that, right? So it's like you said, it's a lot of just driven by talking to those customers, then, right? Of what they're really looking to do, what their overall goals are, right?
Yeah, that's something I'd love to talk with you more about, is how that choice is made, because we'll look at it and think, well, this operation doesn't run that much. For example, in a school, right? We're just serving lunch. But I think a lot of cases with a school operation, right? The staff members will come in, they'll turn the hood on at 5 in the morning, and it'll run until 2 in the afternoon. That's still a large window of time for production of just the lunch, when the effluent and the ovens are maybe running for only, at full volume, are only running for an hour or two. So how do you guys go about that normally, as far as trying to balance between an operation that seems like it's kind of sporadic versus an operation that is, appears sporadic but is actually running pretty consistently?
It really is about the operations. It's about how they're doing things. So when you talked about a school before, right? They have a lot of prep, right? Like you said, there's maybe a block of 2 hours, 3 hours in the day where different age school kids are going to be coming through. They're going to be eating. They have different times. So that's actually a perfect situation for a demand control ventilation, because they're going to have a lot of that prep time where they don't really need it to be running all of the time. In those early morning times, 7 to maybe 10 o'clock, 10:30. But then once they really start to ramp up, they're going to want that more. And when you talk about how everybody looks more at energy efficiency now, right? But then when you look at a place like maybe like a small strip mall that has like some sort of little fast food style restaurant, right? They're going to have, maybe they have low ceilings. We have to have the lower style hoods, the low proximity style hoods. I think that's going to be a perfect situation for more of a constant volume, because they're going to be in there. They're going to be really, when they're cooking, they're doing things. They have output, right? It's just one after another, right? Absolutely. So even their prep time might not really be like a true prep time like you'd see like in an institution, right? In those types of cases, we look just for the constant volume and just the overall how things work, because everything's dictated off of the temperature underneath the hood and what those temperature probes are sensing. I think there's different places there where different products make sense. And then when we're looking at areas, right? Areas of the country that we're designing in. Some things need more cooling, less cooling. We need heat where we are here in Wisconsin, but some other places it's not really that big of a deal, right? When we think about like West Coast or down in the Southeast, it's not as big of a deal. But yeah, so we kind of have like the array of makeup air units, fully tempered based off of what the need is and how it's really going to be tried to controlled, or even looking at something like DOAS units, the dedicated outdoor air systems that truly fully temper the air, and that can actually take over for the full makeup in the space. But it's really, I feel like a lot of times it's working in conjunction with somebody like those mechanical engineers on projects to really figure out what their overall scope is and what really what truly is the end game for the customers too, because
their capabilities and limitations, right, as far as that building goes.
A lot of times there may be issues that people have had in the past or are just worried about, something as simple as like humidity, right?
Definitely.
So that's where like a DOAS unit is great, because it takes care of humidity as well. So you see all this condensation, coming out from, around the walk-in coolers, from the cooking operation, different things like that, usually is a pretty good sign that something's going on there. So
that's a great point, and that kind of brings us back to that customer relationship in the space planning and design. Is what are those customers' hot points? What are they really concerned about? Again, to touch on like a school building, generally speaking, humidity, dripping water off the walk-in door, totally unacceptable, right? I mean, because culinarians in a school district are not going to go for that. I mean, they expect a much higher quality, much more finished, cleaner, better looking operation. Someone that is operating an operation that's really more nuts and bolts. They're not quite as concerned about how things look as more as how things function and sort of, I guess, being cost conscious, right? It comes back to that whole layout and design piece. What are the concerns, right? To kind of touch on that again. But that's very interesting with the humidity control, because it's always a big deal, especially here where we've got these cycles, right?
Right.
In Wisconsin, we'll have 100% humidity, 100 degrees one day, and then maybe 3 or 4 months later, it can be no humidity problems at all, but it's 0 or 10 below. And our air systems certainly are going to be the first place that we notice those conditions.
Yeah, and that's where like, even in a space that we're sitting in here, it can be so much different because, in this front of house here, we have high ceilings, everything is just, kind of being introduced into the space here. But because we were able to work with some of those different players in this design, right? We were able to figure out, okay, so they're going to have essentially transfer air from, different air handling style units, like, much like a DOAS type of unit. That's going to be bringing air in, and then that's what's actually going to be, making up the air for this exhaust hood. But then when you go into more of like a back of house situation, we can use what, I guess you deem as cheap air, right? Where it's truly just a makeup air unit. It's going to be either just raw air, maybe heated air, and that's going to come and be introduced right at the face of the hood, by a supply plenum there, and just basically introduce an exhaust and kind of complete that system, right? And then at the end of the day, right, when we kind of finish up a project, always the best thing, as long as somebody's going to be able to come in and do that balancing, and then there's different things that we have, especially in our products, that make it easier for people to adjust. Whether it's just a little dial on a motor to be able to adjust it up or down based off of need, and then that also comes into play, like different smoke tests. So we talked about before, right? Like the charbroiler, making sure that smoke that it always is going to come off of a charbroiler is going to be taken care of, and it's going to be exhausted. So in those cases, we can really ensure and make sure that balance is happening, right?
Sure.
Because too much exhaust is a bad thing just as much as too much or too little as supply is. Yep.
No, I love what you said about bringing that team together, and I think that's something that's one of the most important things that we do at Boelter, as an advocate for the client, is sort of take their picture, their dream, right? This is the kind of kitchen we want. We've drawn a picture of this kitchen in either a two-dimensional plan or three-dimensional rendering or what have you, and that's all great. But what I think we really pride ourselves on is sort of taking it the rest of the way and getting those engineers involved, the architect, of course, involved. Architects are a little bit more involved naturally, but I think sometimes those electrical, plumbing, mechanical engineers are maybe not necessarily as allowed in on the design end as maybe we like to have them. So we always push for that, and maybe even force that in some instances, right? To make sure that at the end of the day, the whole thing was thought out as the best it could be. There's always hiccups. There's always things that are a little different that have to be worked out in the field, and I think that's where Accurex comes in as far as being able to be on site, help us figure out those little nuances and things that are associated with the building. But the more front end work we can do on that part, right, the better.
Absolutely.
And that's sort of critical to having the system work.
The exhaust system, the kitchen ventilation system, especially when you're just in the kitchen and you're looking at the hood, it's something that needs to be there, right? Like you need to have it from just general comfort. You have the smoke, the grease-laden air. We want to take care of all that, but then we also want to protect everybody in there too, right? So we talk about fire suppression systems. You need that, but you also want that, right? Because like you said, with what Boelter does to just kind of go the extra step, go the extra mile for all the customers. I think that's kind of what we all want to do, right? And that's why we try to partner everybody together so well and so tightly, because it's their livelihoods, right? It's our customers' livelihoods of just
absolutely
everything that they are. It's their dreams. It's everything. So at the end of the day, we want to have it be perfect, right? We would love to continue the conversation with you around your specific needs. You can find your local Accurex representative or reach out to us directly at accurex.com or call 1-800-333-1400.